Sir, I think you are muted.
Sir, you are muted, I think.
Good morning, students.
Morning, sir.
Good morning, sir.
Morning, sir. Good morning, sir.
Sir, can you
Morning,
please
sir.
do us a
Can you hear
favor?
me? Hello.
Sir, change the setting, sir. Just make you yourself as a presenter.
Good morning, students. Can you hear me?
Yes, sir.
Yes, sir.
Okay.
Sir, may I keep you on attendance?
Yes, sir.
Well, so the topic we were discussing was about surface integration in the last class.
Excuse me, sir.
Yes.
Sir, before starting the class, please make everyone attentive because someone is removing.
Yes, sir. Me too. Someone is reviewing me. So please make yourself as a presenter, not as.
So where to do that?
Options, yes, sir. In the options menu, show meeting, show device. Sir, meeting settings.
I'll be joining from the web page.
Sir, I think at that three triple dot beside people
Have been muted.
where we all are.
Yes, sir. There is an option on the three dot meeting. Open it. Sir, open it. Yes, sir. There is an option. Meeting.
Sir, you are muted.
So you are muted, sir. Mic.
So where is
Sir, meeting details.
meeting details means we are here. Then.
Meeting options. Meeting options.
Yeah,
Sir,
so
yes, sir. There is an option.
only one, right?
Yes, sir.
Yes,
Only,
sir.
only means save.
Sir, and allow reactions also. Sir, you can put that at no.
Sir, now it is okay, sir. Now it is okay.
Okay.
So there is
Thanks,
allowed.
sir.
Sir, in the allow reactions, can you please disable that? Can you again open that setting? In the allow reaction, change to no.
Now reaction this one. Save. Okay, so I think this is all right now.
Yes, sir.
Yes, sir.
Yes, sir. Thank you.
Yes, surface integration, as I mentioned earlier, the basic concept of integration is that there will be a region of integration, and in that region, a function, either vector or scalar function is defined. Okay, so to define the, so how we define the integration associated with different kinds of regions and functions. So essentially, we divide the region into small parts, and from each part we take a point, and at that point we calculate either a scalar function, value of a scalar function, or a vector, and we use that vector to find find some number. It may be find some number, we cannot say always because it can be vector also, but in this particular case we are finding a number, calculating at that particular point, specified point from a region. Okay, and then we are taking a dot product, a normal component of it, and that is giving a number, and then we are multiplying that functional contribution with the area of the surface. And in the process, we are finding this sum, and finally, if we are considering the limit of this, and if it exists, it is called the surface integration. And ds, this ds, which is a portion of the surface, differential associated with the portion of the surface, can be changed to Cartesian form in this way. Dx dy divided by n dot k. This is basically cos theta, angle between the surface delta s and the projection. Okay, so using this formula, we convert the surface integration to a double integration, which we already know how to evaluate it. And while considering the surface integration projection, we have to be little bit careful so that the projection is 1-to-1. Otherwise, we have to treat the problem differently. Okay, different portion of the surface differently to ensure that the projection is 1-to-1. Okay, so I think we have discussed one problem. We have in fact solved one problem, and associated with scalar function phi defined in that region of the surface, we define surface integration in the similar fashion. Only thing is that f dot n is replaced by this phi, and the projection of ds is similar, dx dy divided by n dot k. N is the unit normal to the surface and k is the unit normal to the xy plane, provided this projection is allowed. Well, so now if the equation of the surface is given in this form, then we can calculate or simplify this dot product. So n is nothing but grad of f divided by mod of this, and which can be written in this form. It can be shown that if we take the dot product, we will get this, and finally we can express this surface integral in this form: phi into root over del f del x square plus del f del y square plus 1 dx dy. So now today I will discuss one such example. So example number 3. Example 1 we already discussed. Now you look at this example for the function phi xy z x square plus 2y plus z minus 1. This is our function, and we have to show that we have to find the surface integral over S. And what is S? S is the region consisting of the part of this plane lying in the first octane, and we have to show that the value of this integral is equal to 3/4. Okay, so here I should have used the double integral sign, so there is a typo. I will correct it. Well, so x square plus 2y plus z minus 1. This is the function. X square plus 2y plus 2y plus z minus 1. This is the function, and the plane 2x plus 2y plus z equal to 2. Yeah, so now what is our function? Function phi x y z. This is equal to x square plus 2y plus z minus 1. This is the function, and therefore we need to calculate a normal vector to this surface. So therefore this is equal to so I have to mute all. So what is your this is the function, and then no
2ik plus 2jk plus kk by 3.
No, not control Z. This is not my n. The plane is 2x plus 2y
I plus J plus K
plus J z equal to 2. This is the plane.
Equals to 2, sir.
Yeah, so therefore what is your n? N should be, this is the surface actually, this is your S. Okay, so this is equal to 2i plus 2j
plus
plus K by 3.
by 3. This is your n, and then n dot k
1 by
absolute
3
equal to 1 by 3. Therefore, it turns out that this is equal to phi ds. This we have to find, and it can be converted to a double integral. R is the projection of S on xy plane, and by the construction we can understand that this projection is 1 to 1. So therefore we can go ahead and calculate the double integral 1 dx dy divided by 1/3. Okay, so now we have to change this z because this is a function of xyz, and we are calculating basically the surface integral over the given plane in the first octane. Therefore, we will write R is the projection. I am not mentioning over here, but during exam you have to mention z is equal to plus 2 minus 2x minus 2y minus 1, control Z minus 1,
Yes, sir.
and 3 will come here, and dx dy, and this is equal to 3 r x
minus 1
square
का whole square
x
minus 1 का whole square.
अच्छा
x plus 1 का whole square.
x plus 1 whole square, 2y is cancelled, x square x minus 1 whole square,
x minus 1 का whole square, sir.
So x minus 1 whole square dx dy. Achha, so now we have to look at the region R carefully. So let me draw it over here. And draw it over here. So what is your x? If we take the projection on xy plane, this is xyz, and the plane is 2x plus 2y. So basically it will intersect xy plane over here, x-axis over here, 1 0 0 point, y-axis here, and z-axis somewhere here. So this is the plane. And what is your R? R is the projection of this on xy plane. Therefore, so this is the projected region. This is your R. This is your R. And S is this. S is the triangular region. You can understand now. Now, let us separately focus on this region, projected region R. Separately focus on this region R. It is a portion of the xy plane. Y, this is our y-axis. If you look at the projection, and it will be 1 1.
Yes, sir. X is equal to 0, so 1. Y is equal to 0 to
So
1
what
minus
is the
x.
this line? Z is equal to 0, so you will get y is
X plus
equal
y is equal to 1.
2 minus x. 2 minus 1. 1 minus 1 minus 1
Yes,
minus a. And this is 1 0. And there are two possibilities now, you know.
Yes, sir. 0
Either
1.
we have to
Yes,
look
sir.
at the region from this side. This is more convenient for
0
us.
to 1.
So x will vary from 0 to r, and for each values of x, as x is varying from 0 to 1, y will vary from this 0 to 1 minus x.
1 minus.
So therefore it is now convenient for us. Y will be from 0 to 1 minus x, and x will be from 0 to 1. And first we will perform y derivative, x minus 1 whole square dy. This thing we will calculate, and whatever we will get, we will find the x derivative. You will get a function of x over here, and then we have to evaluate the x integration. And note that while evaluating y integration, we will consider x to be constant. And you check it whether you are getting the desired result, probably 3/4. So you check this thing. It should come as 3/4 if you complete this integration.
Yes, sir.
Okay, so therefore I guess that you can handle surface integration now. So basic thing is that if you understood double integration, triple integration, then you can manage any kind of integration, and if you have the idea of integration as a whole. Now you look at the problem number 4. Find the surface area of the portion of the plane bounded by this. This is square, unit square. That means what we have to do, we have to just, so in this case we are in 2 dimensions rather. So surface into if we want to determine the surface area of a region, then what we have to do, we have to take the function phi to be equal to 1. Okay, so if we take, so if you look at the definition of this phi ds over some region S, then you will be, it is not difficult to convince yourself that if we choose phi is equal to 1,
two-dimension body.
Hmm?
Sir, for two-dimension body, phi equal to 1.
Yeah, any for any case, it will give you the area of the surfaces of the surface. Because if you look at the definition, what are these basically? This is basically limit n tends to infinity summation phi k or delta sk. Phi k is 1 actually in this case. K is equal to 1 to n. And we choose this n tends to infinity in such a way the areas of the elementary surfaces becomes 0. So therefore this is nothing but the sum of the elementary elementary areas. So we'll get the entire area in this case because phi is equal to 1. So therefore, if we are willing to determine the area of this rectangle, this square 1 0 0 1, so which integral we have to consider? So we will consider phi is equal to 1 and evaluate this double integral over this region R. So this will simply give us the area. And what is your ds in this case? We are already in the xy plane. Ds will be equal to dx dy or dx dy. So this is nothing but 0 to 1 dx dy.
This divide.
So you will get 1. As simple as this. And for the next problem, next part.
Sir?
Yes.
So many of my friends are claiming that they cannot join the class from B section.
So what is the problem? What could possibly the problem?
Just now we have joined, sir.
They are saying that they cannot join from the link or from the calendar.
They're able to join some other meeting with some like where you are not there.
So where are we now at this moment? Is it in the right meeting? Are we in the right meeting or?
Yes, sir, we are in the right meeting. Someone else started
Yes, sir, we are in the right
meeting.
Some students are unable to access it. You know, my section E, they are unable to check it. I have sent many times the link, but they are not seeing you.
Yes, so there is some glitch from some side because we are sharing the links. Even then, they are not able to join.
No, no need to share. They are the members of the group. They are included in the group. Just directly they can enter the class.
So they are not able to. That is the problem.
Okay,
yes.
so
They're landing up in some other place where some other meeting is going on.
So meeting details. Let's see.
Share your link by yourself in chat box, sir. I will copy and paste.
Acha, so this should not be a problem, no? Allow reactions. I have
No, sir, that is not.
No, sir, no, sir.
Not the
No,
problem.
sir,
Acha,
that is
people who can bypass the lobby.
To the
Yeah,
meeting details and
yes, sir.
copy link and
yeah,
Otherwise,
even one can bypass the
Also,
lobby.
that is
not
the
the
problem.
problem.
That is fine.
yes, sir. Sir, may change it everyone to the organization of the people in the group.
So I have made it to everyone so that one can join using their Gmail also. So
Sir,
it is.
there were multiple meetings set. I think the other meetings which were cancelled, their link has been shared. You know, like 3 meetings are being set in the calendar. You cancel that
Three.
one is yours in the calendar.
Sir, you can go on.
So other meetings are also going on calendar. So what are the meetings?
Sir,
Sir,
here
but
is
I think those are already cancelled, sir. Those are already cancelled.
Yeah, so therefore it should work, I think. Now. So vector calculus, this is going on, you see.
Yes.
And others are already cancelled. I don't know. So ask them to join using their Gmail. If otherwise, I have no idea. Probably this is a technical glitch. By joining, so still, can you confirm that still there is some problem?
There is problem. Many students are even in section C.
Acha, so this is the meeting, no?
Copy link and paste in the chat section so we can share.
Yeah, I am sending it. I think this should work. So please share and yeah, inform me if it is working or not. Sometimes yeah, we face problems. So anyway, so yes.
Can you please return to the previous slide once?
This one.
Yes, sir. Okay, sir, done.
Okay. Well, so in the next case, it is a circular region. So now I have to mute everyone.
Sir, please start the recording.
So it is already started by someone. I don't know. Recording has started.
Yes, sir. Yes, sir. Recording is on.
Yes, sir. Recording is going on.
Okay. Okay, let me continue this thing. And in the second case, region, so we have to find the area of a circular region. Okay, so it is bounded by x equal to 0, y equal to 0. That is, we are in the first quadrant only.
Yes, on XY.
Yeah, so ds is equal to dx dy because we are on the xy plane. So, and you can choose phi is equal to 1 and you will get the area. So 1/4 of pi r square, r means 4. Pi into 4 square. So that result you should get.
Sir,
so this, yes.
Sir, if it was in second quadrant, then it would be ds would be minus dx dy.
No. dx dy only. Only you have to play with the limits then. Limit of x and y in that case. Okay. ds is it will be equal to dx dy as long as you are in the xy plane.
Excuse me, sir.
Yes.
The link that you shared lands them up in the meeting options page, not in the meeting itself.
That I have shared.
The link that you shared is for actually the meeting options page, not the meeting itself.
Okay, so where is the meeting link I can find?
So there is a share invite option over the participants list. You may try that.
The right side.
Share invite
So
on the top.
this one.
Yeah, you may try that.
Copy link, this one.
Yes, so you may paste the link in the chat. You can copy that accordingly.
After the
Let's see if it works. Control C. Control C.
I think just you can click.
তো হয়ে গেছে স্যার।
Huh?
Sir, these
স্যার এবার পেস্ট করে দিন।
আচ্ছা, so same thing it is showing, same link. Is there any difference in the numbers?
No, sir.
Same. But this should not require. We should not require this thing because you are in this group.
Yes, I know,
so
but there is some glitch from some side. I don't understand where it is.
yeah, that is the thing. I also cannot understand this. Can I start can I just leave the meeting and end the meeting and start afresh? Will it work?
Sir, yes, sir. Yes, you can do that. Yes, sir. Yes, sir.
So let me just try this one, and please no one start from your side. Okay, so I will start the meeting. Okay, so that I am trying.
Stop the recording, sir. Before you end the meeting, stop the recording.
Stop the recording.